All right. So let's see example 1. A point on the unit circle. So show that the point root 3 over 3, comma, root 6 over 3 is on the unit circle. Well, let's just plug in. So x value in here equals to root 3 over 3. So that's our x value. Right? And that's our y value. We just plug in to see if x squared plus y squared equals 1. So let's put in. So root 3 over 3 we square plus root 6 over 3 we square. Root 3 squared, that's 3. Now, 3 squared is 9, so I have 3 over 9. Root 6 squared, that's 6. And 3 squared is 9, so I have 3 over 9 plus 6 over 9. 3, we have common denominator of 9. 3 plus 6, indeed 9. So I have 9 over 9, which is 1. So perfect. So that means this point is indeed on the unit circle. The unit circle has a representation of x squared plus y squared equals 1. Okay, try to remember this. Try to nail this into your head. It's one of the famous representations for a unit circle. Unit circle on xy plane, centered at the origin with a radius of 1.
Professor, I have a question.
Yes.
Before, yeah. So the square only applies to the denominator?
The square applies to both. You're talking about this, right?
Yeah, that.
Apply to both.
No, because I'm seeing the same thing. Like 3 over 9 and 6 over 9. So to me, I thought like the 2 only apply to the 3 to make it 9.
Okay, that's a good point. Let's write here. Let's do each one. So I have a square root of, let's do each one, 3 squared. What's that? When we square this term, I'm going to put parentheses around here. What is this? Square and square root are opposite operation, like a plus and minus. We square root this 3, then we square this 3 as if we didn't do anything to 3. Does that make sense?
Yeah.
Okay. So now do you see we did square this square root of 3? This here is a 3. Here is the square root of 3. So square root of 3 squared is a 3. Make sense?
So it applies to both the numerator and the denominator.
Of course, because we have parentheses.
Yeah.
Without parentheses, so if the square is here, then we only apply to the denominator.
33. Okay.
Okay. Okay, good. Okay, always ask questions. Whenever I confuse you, ask me questions, all right? Okay, example 2. Locating a point on the unit circle. Let's see this point. So this point is the square root of 3 over 2, comma, y. Well, let's find out y. So we need to find out y. So let's put that back again into x squared plus y squared equals 1. So x is given, root 3 over 2 squared plus y squared equals 1. We're trying to solve for y. So we get a y squared equals to 1 minus root 3 over 2. What's root 3 over 2? Square root of 3 squared, that's 3. 2 squared, that's 4. So 1 minus 3 over 4, that's a quarter. Right? Because 1 can be changed to be 4 over 4. Then we square root both sides, so we'll have y equals to plus minus half. Right? Because square root of a quarter, square root of 1/4 equals to half, right? We get 2 points. So one point is root 3 over 2 positive half. Another point is root 3 over 2 negative half. Let's see. So I have 1 somewhere here. So 1 point somewhere here. Right? Another point somewhere here. It's positive half. With negative, oh, this point should move somewhere here. With positive half and with negative half. Make sense? Okay, the second example. Terminal points on the unit circle. What do we call terminal points? All those points on the circle, we can treat them as terminal points. What does it mean, terminal points? We think as an angle. So let's see the point ends up here, right? We see this red color curve, and then we would call this line terminal line. Okay, why we call this terminal line? Because this measures this one. We want to measure the angle. This is the angle we measure. We are going to call this angle maybe T. In this case, T, the angle T. So how do we measure angle? We start from positive side of x-axis. Right? So this is a starting point. Then we go counterclockwise. Okay, counterclockwise. Counterclockwise. Counterclockwise means positive angle. Okay, so the angle is positive. Counterclockwise. And I can keep going, right? I can keep going. Then I have another one. I have a 360 plus this t. Also end up here. And I can keep going. 720 plus t ends up here. So this is, we call this a terminal point, and this line called terminal line. Okay, a lot of angles share the same terminal point. A lot of angles ends up at this point that differ by 360 or 720, so on and so forth. So clockwise measure we call negative angle. So this is positive angle. If we go down here, see the second circle, see the red part, right? The angle is negative. So this is a clockwise counting. Clockwise, negative. This angles we measure negatively. Now, of course, this point is a terminal point, right? Or co-terminal point. Many angles ends up at this point.
So, Professor?
Yeah.
Does that mean whenever an angle is a negative, is a clockwise?
Yes. It means the angle being measured clockwise. Good job.
Start again, please.
I'm sorry?
Can you repeat that?
Yes, I said you are right. When the angle, let's say negative pi over 2, right? Let's use one example. Maybe negative 90 degree. Negative 90 degree is just exactly up to this. Up to this.
Okay.
Okay. We will see more. All right, we'll see more.
All right.
Let's see this one. Let's see, we have these 4 circles, right? Pi, we know pi equals 180 degree, right? Pi means pi radian. So when we talk about angles, angles can be measured in 2 units. So one is radian, and another one is called a degree, because 180 degree. This is the relationship. Pi is 3.14, goes on forever, like all your number, irrational numbers. So pi rad equals to 180 degree. So let's see this one. So if we measure positively, it's counterclockwise, right? From this point, this is a starting point, up to this point, the angle is 90 degree, or pi over 2. Because pi is 180 degree, so pi over 2 is 90 degree. If we keep going, t equals pi, the angle equals pi, and that also means 180 degree. If we keep going more, the third circle, that means 180 plus 90, which is 270. 270 equals 3 pi over 2. Right, that's degree in degree form. So let's put over here. So pi over 2 rad equals 90 degree. But in calculus, we do not use degree anymore. Future, okay? we always use radian. We always use pi to represent. So pi over 2 is 90 degree. Pi is 180 degree. 3 pi over 2 is 270 degree. 2 pi is 360 degree. So a circle, well, starting from this point, we will run a circle, end up at this same point. It's a 360 degree or 2 pi. We prefer the pi form, 2 pi. All right, let's find these terminal points. So t equals to 3 pi, right? Positive angle. Positive angle, we go counterclockwise. We start from this point, right? We run, oops. We start at this point. We run a circle. That's 2 pi, right? But we need to run 3 pi. So we keep going. So end up here. That's 3 pi. So we run one circle, then pi, 2 pi plus pi, that's 3 pi. So 1.5 circle, that's 3 pi. Now the second one is negative pi. Well, negative, we go clockwise. Negative, we go clockwise. We start from the same point, but we run clockwise. So that's negative pi. That's negative pi. The third one is negative pi over 2. Or negative pi over 2. Start from the same point, run clockwise. Right? Run clockwise, pi over 2. That's negative pi over 2. So on and so forth. That's how we measure angles. Let's see this one. This one is saying square root 2 over 2, square root 2 over 2 is also a point on the circle. You may check that on your own, okay? You see this x value and the y value are the same. And this point is also on the straight line of y equals to x, because both values are equal to each other. You could try on your own to see indeed they're equal to each other. Because square root 2 over 2 square, that's half. Square root 2 over 2, right? That's 1 over 4, 2 over 4. 2 over 4 is half. Half plus half indeed equals to 1. So there are some special angles. 0 is a special angle. Pi over 6 is a special angle. Pi over 4 is a special angle. Pi over 3 is a special angle. Pi over 2 is a special angle, right? If it's difficult for you to remember for this class, for these trigonometry functions, we need to remember some special angles. 0, pi over 6, or pi over 6, 30 degree, right? I'm going to only write D here. Right? Pi over 4, 45 degree. So in the beginning, if it's difficult for you to remember, try to remember in this. Then pi over 3 is 60 degree. You can use this formula, right? Pi equals to 180 degree to convert. Pi over 2 is 90 degree. Then we have pi. We have 3 pi over 2. 3 pi over 2 is 270 degree. Then we have 2 pi. 2 pi is 360 degree. Also same as 0, because we go back to the same point. And on this one, so the point is, so we measure the angle to pi over 6. What's the x value? The x value is root 3 over 2. The y value is half. At pi over 4, x value is root 2 over 2. Y equals root 2 over 2. All right, so on and so forth. And we will use sine, cosine to represent those. So let's see example 4. Find terminal points. Find the terminal point determined by each given real number t. So let's say t equals negative pi over 4. Well, measure negatively, right? Measure negatively. So negative pi over 4 is this one. Right, this one, negative pi over 4. Positive pi over 4 is this one, at this point. The second one, 3 pi over 4. 3 pi over 4 is little bit less than pi, right? 3 pi over 4, if we will convert, so 3 pi over 4, or we can write as 3 over 4 pi. Okay. So how do we convert? We do 3 over 4 times 180 degree. We write D here, degree. So pi means radian. Usually we use RAD. D means degree. Let's see. So 180 divided by 4, we can divide by 4, right? 180 divided by 2, we get 90. 90 divided by 2, we get 45. So we get 3 times 45 degree. But what's 3 times 45? 3 times 5, 15. 3 times 4, 12. That's 135 degree. That's how we convert from a radian to degree. Sometimes if the radian does not make sense for you, maybe you can think about degree, because degree usually make more sense for most of people. So 3 pi over 4 is 135 degree. Then last one, negative 5 pi over 6. So measure this way clockwise. Negative pi over 6. We can do the same, right? We can multiply by 180, and we'll get into a degree form. Okay, something called a reference number, right? As we talk about, I can run circles, right? I have this terminal point, and this terminal point could be a co-terminal point. Why? Because I can keep running, right? I would have another, I would end up here again. Oops. Right? I can run one circle, then end up at this point. I can run 2 circles, then end up at this point. I can run 3 circles, then end up at this point. So usually we call this point co-terminal point. And this line we call co-terminal line. Then, there's so many angles we can talk about. So what do? Now we make a reference number. We make a reference number. So we take the smallest positive number to talk about. When we talk about this point, we don't want to talk about this point by running 1 more circles or 2 more circles. Just talk about the point from the starting point, run this much to this. So this positive number, this one, the smallest positive number, measure this angle, we call reference number. Let's give an example. Let's say we run this much, right? T equals to pi over 4. So T equals to pi over 4. And if I keep going, I can run 1 more circle. I would have T equals to 2 pi plus pi over 4. I can run 2 more circles, right? I would get T equals to 4 pi plus pi over 4. So I'm going to talk about 4 pi plus pi over 4, 2 pi plus pi over 4 at the same point. I want to choose a representative to speak for them. And this representative will be the smallest positive number, which is just pi over 4. Right? So we call this one reference number. So pi over 4 is a reference number for n into n pi plus pi over 4. Similarly for this one, if I have this one, T equals to, because this angle happens in the second quadrant, right? This angle happens in the first quadrant. Second quadrant, maybe I have T equals to, let's use a 3 pi over 4 we had before, 135 degree, right? Now I can add 2 pi to it, I can add 4 pi to it, add 6 pi to it, 8 pi to it. So there's so many angles. I'm going to use 3 pi over 4 to talk for them. So that's my reference number. So 3 over 4 pi is a reference number for n into n pi plus 3 over 4 pi. So the rest of the same idea. This angle in the third quadrant, right? So this is the first quadrant, and we call this the second quadrant. Oops. So this angle happened in the second quadrant. And this in the third quadrant. I will need 3 bars. Third quadrant, and this in the fourth quadrant. Fourth quadrant. Oops. Okay, so too bad. So this angle in the fourth quadrant, right? Let me write this way. Oh, okay, this is better. Fourth quadrant. So the points. So we can talk about the points on the unit circle in the first quadrant, in the second quadrant, in the third quadrant, and in the fourth quadrant. Right. So a point can end up in each quadrant. And then we use the smallest positive number to speak for all the coterminal points. Okay, let's see example 5. Let's try to find the reference numbers. So t equals 5 pi over 6, right? Now, let's talk about one more thing, actually. So we are in a trigonometry. Right? We're talking about trigonometry functions. This covered my point. So what are we going to do is what we need to talk about triangles. So when the point is on the first quadrant, we make a line. We call this coterminal line. I don't need the, what do you call it? I don't need the, right. I can make a red rectangle. So what do I do? So with this point, I'm going to make a line connect to the origin. So from the origin 0, 0 to this point. And then I can drop a perpendicular line to the x-axis. So now I have a rectangle to talk about. Right? To meet a rectangle. To meet a rectangle in the first quadrant. And later on, we're going to use sine, cosine, tangent value to talk about this rectangle. And similarly, if it happened in the second quadrant, you can also make a, what do we call it, a triangle. So what's a triangle? The triangle is the same thing. I'm going to connect the point with the origin. It's one line. Then I'm going to drop a perpendicular line from the point. So we see a triangle in the second quadrant. Okay, so we can talk about the triangle in the second quadrant. We can talk about this point. Is a point on this rectangle. And this point is on this rectangle. Similarly, here I can connect those 2 points. And I'll drop a line to the x-axis. Perpendicular line, all right, which means make a 90 degree with the x-axis. But then I see I have this triangle to work with. So I have a triangle in the third quadrant. And of course, exactly the same thing. I have a triangle in the fourth quadrant. I connect the point with the origin. I drop a line to the x-axis. Then we have a triangle. We have a triangle in the fourth quadrant. Right? So this point, those points are points on the unit circle, and also a point on the red triangle. So we can use the properties of a circle. We can use the properties of a triangle to analyze this point. All right, so let's see this one. So t equals 5 pi over 6. right? So if we draw the angle, we see t equals to 5 pi over 6 ends up here. But we want to find its reference number. So how do we do? What's the reference number here for that angle? Oops. So for this one, it's just this one itself. For the first quadrant, if in the first quadrant, it's just this. In the second quadrant, we're going to talk about, instead of talking about this big angle, we're going to be talking about the angle inside this rectangle. What is it? It's complementary angle. This is a actually supplementary angle. Means those two angles adds up to be 180. Does not allow me to. Okay. That's this angle. So this angle formed by x-axis and this coterminal line. Okay, this coterminal line, this angle. Let's see. So if it's in the second quadrant, okay, reference number, let's write here. The reference number in the first quadrant, just itself. First quadrant, just the number t. Okay, it's itself. Second quadrant is pi minus t. Pi. Second reference number is pi minus t. The pi minus this much is this complementary angle. How about in third quadrant? In third quadrant, we see we're talking about, instead of talking about this huge angle, we're going to be talking about the angle here, this one, this angle. So this angle is a reference angle of this. So what is it? It's a t minus pi. Okay, t minus pi. What about on the fourth quadrant? On the fourth quadrant, instead of talking about this huge angle, we're going to talk about this angle. This angle. This angle inside the triangle. This angle. Right? This angle. I made this too big. We're going to talk about, so this is a reference angle for this. For this. So what is it? It's 2 pi minus t. 2 pi minus t. That's how we find each reference angle. You know, the book called reference number. We could call it reference angle. Reference angle. For the first quadrant, just the angle itself. For the second quadrant is pi minus the angle. The third quadrant is the angle minus pi. Fourth quadrant is 2 pi minus the angle. Right. Now gradually we'll get used to this. So for the first one, A, we figure out is in the second quadrant. We will just use pi minus it. We do pi minus the angle. We get a pi over 6. So pi over 6 means this angle is pi over 6. Right? This angle. The angle inside this rectangle. The B is 7 pi over 4. 7 pi over 4 is bigger than pi in third quadrant. So if it's in third quadrant, we use the angle minus pi. So we do 7 pi over 4. Oh, 7 pi over 4 on the fourth quadrant. I was wrong. It's not on the third quadrant. It's on the fourth quadrant. On the fourth quadrant, we do 2 pi minus the angle. We do 2 pi minus the angle. We get pi over 4. That means this angle inside the rectangle is pi over 4. The negative 2, C, negative 2 pi over 3 is in the third quadrant. Third quadrant, we do pi minus. In the second quadrant, if we try to draw yourself. In the second quadrant, we would do that one minus, let's see, negative 2 pi over 3, right? Negative 2 pi over 3, we measure this way. So negative 2 pi over 3 is somewhere here. So third quadrant. We would do, what would we do? We would do the angle minus pi. But this is a negative. right? This is negative. So we would want to find the positive term. So we would do 2 pi minus this angle. 2 pi minus this, we would get this one. Then we minus pi. T equals 5.8 radian. So this we need to convert into radian, convert it into degree to see in which quadrant. All right, then if we do that, we figure out that that's in fourth quadrant. If in fourth quadrant, we do 2 pi minus the angle. Okay, so this is how to find the reference number. It depends on which quadrant. So next class, we're going to talk about how to find. So if we're given the angle of the point of the coterminal line, how do we find the point? So let me give you some homework. So homework. I will write number later, okay? So homework 5.1. Let's try to do 1, 2, 3, 4, 5. You know what? 1 to 8. 1 up to 8. 1 up to 8. Then this one, but you also learned to do this too. 1 up to. Okay, actually, let's do 1 up to 8. Let's do a little less. 1 up to 6. So 1 to 6, 9 to 12. Right, that makes 10 questions. Okay. So homework for today. 1 to 6, 9 to 12. All right, anybody has any questions? Okay, so this homework, 1 to 2 is a conceptual homework, right? Conceptual to make sure we understand the idea of this section. The 3 and 4 is try to find the points on the unit circle. All right, if no questions, I'll see you on Friday, all right? We're going to keep talking about this unit circle and the triangles in 4 quadrants. Okay, thank you. Thank you, guys. You guys are doing a great job, all right? Keep up.